has changed a little bit, which is why you may have noticed that everything is kind of all around the place, really. But so we have 3 projects. We have Rain Cloud Core. Whoa, that's not what I meant to do at all. What are you doing? We have Rain Cloud Client, and we have Rain Cloud Server. So this is the entire setup for Rain Cloud. So Rain Cloud is what I've given. It's a name that I've given to the entire kind of server side of Rain. So cloud because, well, clouds have something to do with rain, but also cloud because cloud is like the whole cloud kind of computing situation. So I quite like that name. Anyway, we've got 3 projects that I've already worked on. Server has nothing in it right now. Core is kind of where everything's being implemented right now. And client is kind of just like a bunch of test cases, really. I'm gonna have to set up this workspace properly as well, by the way, guys. What I will do is probably bump this up to 12. So we want consoles, and we want to go to Java, code style, organize import, set that to 1. Okay, cool. So I'm kind of still working out the API and everything, and I'm kind of working on this like on the fly. So we don't really have anything concrete yet. Everything's subject to change and probably will change. So lol. But hoping that it all works out. So how's the audio? Is the audio all is the audio good? I hope the audio is good. I think so. I'm just gonna assume it is. Twitch is being a bit weird right now for me, so sorry. Okay, so let's begin. Audio's great, good. I'm going to just pop that chat out. Pop out, cool. All right, cool. So here's the situation. I'll walk you guys through this, and those who are here early, so those who are here already and watching the stream, you guys are going to benefit. It's going to benefit you, really, because I'm not going to go through this stuff multiple times. In fact, you guys are going to be in charge of educating everyone else in the chat who will inevitably ask how this works later on. So right now, this is the way that this works. So just quickly, I'm going to explain exactly what I'm going to be working on this live stream, as well as the kind of the overall scope and all the plans for this and what's going to happen. So basically the idea is, and also all of this will be uploaded to the Cherno Archive channel, which is youtube.com/c/Cherno Archive. So you can definitely catch that later if you miss this live stream or if you have to go halfway through, etc. Okay, so what's up with this, and why am I doing this, and why is this happening now, and and why, just what is this really? So, and why am I even doing this off videos or whatever? So basically, here's the deal. Right now in game programming, if you haven't watched the latest episodes, I'm finally getting around to implementing multiplayer, okay? And multiplayer is quite a big series of things that need implementation. But the biggest part of multiplayer, as you might be able to guess, is the entire kind of let's send data in between 2 computers, okay? That's kind of the issue. That's kind of the main problem that we want to solve, right? We want to be able to communicate we want multiple game instances to communicate over a network. In order for that to happen, we need to set up some kind of system for sending and receiving data. Now, typically, obviously we will be using stuff like UDP and Java's kind of datagram situation kind of API and whatnot, and that's what we will be using for actual data transmission. But the biggest challenge here is to actually format the data in a way that is both efficient and also good enough for us to send and receive and kind of decrypt and, I guess, encode in a very quick kind of way, because this has to happen in runtime, and this has to happen several times per second, right? We might send as many as 20 packets per second, for example. That's quite a lot, actually, but we can do something like that. In fact, that's probably quite standard. 10 to 20 packets per second might be sent. These have to be quite efficient, hopefully. And we have this whole problem of, hey, I've got like, a bunch of integers and like a float and maybe like a string, and I want to send this. How do I send that data, right? That's kind of where serialization comes in, because serialization is the whole concept of in fact, I'm going to pull out a proper definition for serialization and see what. So serialization is the process of converting an object into a stream of bytes in order to store the object or transmit it to memory, a database, or a file. Okay, so process of converting an object into a stream of bytes. Exactly. It's kind of the process of, we've got all these pieces of data everywhere, and we want to convert that into a stream of bytes. Okay? The reason we would want to do that is actually for two reasons, right? Obviously, right now we're kind of focusing on it for the scope of multiplayer and kind of network communication. So of course we need serialization for that, because we want to be able to convert data into a stream of bytes which we can then send over a network. But we also need that for like save games, for example. So when you want to save the state of the game, for example, you do need to convert that into some kind of series of bytes which you can then write out into a file. Of course, you could do something like XML or JSON and JSON, XML, anything like that. Even just a custom kind of string-based format. You could do something like that, but obviously that's not going to be anywhere near as fast as just binary, because binary is extremely fast, because literally all we need to do when reading something that is binary is take it and put it into memory. In fact, in many cases, we don't even need to do that. We can just memory map it. Now, I don't know how Java handles memory mapping, because I've never done that. Mapped by buffer. Okay. I've never done memory mapping in Java before. And we won't need to. I'm not going to implement it into game programming, by the way. That's a bit silly. Okay, cool. Mapped by buffer, it seems. Anyway, the point is, when you're reading binary data and you need to, for example, deserialize a save game, you can just load the entire blob into memory and then kind of just be like, or even partially load it and be like, hey, this is my value. I'm just going to basically copy those bytes from disk into memory, and you're done, right? When it's a string, you have to pass the string, and you have to, it's all just a mess. It's all much, much less efficient. So binary clearly the way to go for pretty much everything, including file serialization and network serialization, because that's the way we need efficiency in both of those cases. I mean, when you're making a game, you do want loading times to be rather quick, but you also want, it's probably particularly more important for a network kind of communication than it is for files, because you can get away with a lot of kind of string kind of, especially for small games like this one, you can get away with a lot of kind of, let's actually write this out as a bunch of strings. That's fine. That'll handle itself properly. It's just that there is a certain overhead associated with that when you actually begin to send that over network streams. So if you look at something like ChronoChat, that was the way that sent its packets and everything was basically just strings, right? There were a bunch of strings converted to bytes, obviously, to be sent, and then converted back into strings. And then those strings, as you would have seen, would have to be passed, okay? And passing those strings isn't a huge problem, especially for something like a chat program, because that's not like a real-time thing, right? That doesn't have to achieve a frame rate, and that's totally fine. And of course, my entire my entire goal with network chat programming was more or less to kind of teach you guys the basics of the actual network communication side of it. So I didn't want to go into writing this whole format. But since I am doing game programming now, and as in like the series, and I want to actually implement some kind of solid system that will teach you guys a lot about serialization in general, both file and network serialization, I thought I would actually go ahead and implement a proper system rather than just kind of hacks it. Or implement something rather inefficient, which I just wouldn't want to do, really. So anyway, that's the background of what's going on. So what we're going to focus on right now is we need to decide on a format. So I'm going to use a very similar format that I'm actually going to write into Sparky. In fact, Sparky does already have somewhat of a serialization format that isn't actually part of the official engine yet. It's more or less on a separate branch that isn't even on GitHub. But the point is, this is quite a nice way of doing things. It's got a little bit of overhead, but this is more or less, I would say, more of a file kind of serialization thing, and we may need to trim a few unnecessary things for the network version of it. But more or less, this is going to be pretty rock solid. I want to make it pretty rock solid, which is why I'm streaming this right now instead of just on the fly, kind of just popping it into game programming. Because whoops, sorry, microphone. Because obviously I could just be like, you know what? Let's do it live, as in, let's just keep making game programming episodes every time, and I could kind of do this on the fly, but I want to take the time to do this kind of offline, so to speak, even though that's ironic because I am technically online right now streaming, but you know what I mean. I kind of want to do it offline from those videos and kind of get this right first so that I can actually teach something useful. Okay, that's a pretty big rant just then. So I hope you guys understand everything I said. Again, it will all be on Cherno Archive, so it should be all the best. Okay, cool. So let's begin. So right now, this is just a series of tests. You can see it by the name test. They're not unit tests or anything. They're just literal kind of functions that I can call to test certain things. So they're not actual tests, like unit tests that you would find. Yeah, that's kind of the whole deal. This is basically what's capable right now. There is no deserialization things, which is what I'm working on right now, actually. I've actually implemented quite a fair chunk of this. Yes, and unfortunately, I'm just replying to chat and whatnot right now. Unfortunately, yes, this is in Java because game programming is in Java. This is actually a bit unfortunate to do in Java. I'm not going to lie. It's actually kind of annoying because of the way that Java handles a lot of this stuff. Namely, just because Java has no direct memory access. So if I have a float in memory, or I have a string in memory, or I have an object or a struct in memory, I can't just be like, give me the bytes. I have to like manually do stuff to it. It's very annoying. And it's definitely more verbose in this case, and it's also slower. So it's very annoying that this stuff is in Java, but and it's also going to get probably pretty advanced Java. Like, not really. I mean, Java's not really that advanced. I don't think I'm using anything really that advanced anyway here. But anyway, let's take a look at this and we'll kind of see where we're at. So to walk you guys through a lot of this, and this is all work in progress. This is probably about an hour and a half, maybe 2 hours that I've spent on all this thus far. It's very all over the place as well. So we have, okay, so database is probably the beginning of everything. So a database is actually a file that you, a database is a file or a packet that you just, that's like the entire kind of thing, right? I'm going to stop right here to answer a question from the chat, actually, that Dylan Player 00 has. So, well, it's more of a statement. He says, yeah, you don't need to deal with headers, which I don't get. So, header files, yes, are absent from Java, but there is actually a very good reason for header files. And the thing with header files is the whole concept of having prototype functions. So you have functions, either class functions or methods, or actual procedural functions. that have a prototype but no actual implementation. That is vital, okay? The reason, a good reason that it's actually like that and that it has to be like that is because of platforms. So different platforms require different implementations, but you still want the signature of the method to be identical. So for example, if I had something like, hey, let's read a file, and this will return to me a pointer of the data in memory, right? The way that the platform reads the file is going to be platform specific. So you might have that one read file method implemented 4 different times, right? One for Windows, one for Mac, one for Linux, one for Android, one for PlayStation, one for Xbox, whatever, right? You'll have a different implementation of that one method so many different times, but obviously you will set your compile settings and whatnot to compile the correct version and link the correct version of that function based on the platform you're compiling for. If you didn't have header files, how would that work? Like, it wouldn't really work. Obviously, you could argue the case in point that, yeah, I would just have like 4 different versions of the actual implementation with no header file, and that's even worse. Like, that gets really messy. So there is a reason that it's like that, and there is like there's a good side to it as well, and that is when you actually do have a platform. You want kind of like a platform independent kind of API, but obviously the implementation will be platform dependent. So that's kind of important. I hope that makes sense, and that is definitely a reason why header files are very important. As well as header files, like, they're just definitions of things, really. I mean, you can put anything into a header file, obviously. But I quite like the concept of header files because you can do some pretty cool stuff. Like, for example, you could write an entire shader in a header file, just in a normal header file, and then hash include it into like a string, and then just load that into into like a shader compiler kind of deal, right? And you would do that without actually loading the file. And the good thing is that would actually get compiled probably just like straight into the executables kind of data. So, you know, sorry, microphone again. But yeah, so I quite like that situation, to be honest. Anyway, let's continue on here and get some work done, because that's really what I want to do. So database, let's talk a bit about database. Database is essentially yes, headers are very powerful. Headers are very important, and once you begin working on multiple platforms, as well as, actually, I guess you get deeper into C++, you'll begin to appreciate them a lot more. C++ is my favorite language just because it gives you so much control, and it's just so, I like being in control, let's be honest here. And it satisfies that for me. Anyway, enough of that. So what is a database in this kind of serialization situation? So a database is essentially the best way to picture it probably is like a file. It could be also like a network packet that you send, but it's a file. So a database is a bunch of objects, essentially, okay? So typically databases will have, well, in this case, actually, concretely, not typically, right now a database has a header. Now this is just a 2-byte header, which just identifies this as being a rain cloud database, okay? And the header is literally just the 2 characters, RC, okay? That's it. That's a 2-byte header. Again, these are things you could trim from it if you really wanted to when you're actually going into sending that over a network, but it's only 2 bytes. Like, I'm not, I don't think that's really the biggest concern here. There's a version which is a short. There's 1 byte, which is essentially compression, so whether or not compression is a thing. This is something that, again, gets excluded from the network side of things, because I probably wouldn't compress the data before I send it and then decompress it on the client side, I guess, on the other client, rather, for just ordinary packets. But if you're sending a huge, I actually think C++ looks more beautiful than Java, by the way. But anyway, I guess that's what looking at C++ all day will do to me. The point is, I'm going to kind of ignore the chat for a little bit. I really want like some moderators to get on and entertain you guys while I do some stuff. Anyway, so we have so compression isn't something that you would enable usually when you're actually sending packets. It is something, if you wanted to, for example, use this database format, which you probably would for like sending large amounts of data over a network, such as maybe downloading, let's just say this is a good example actually. Let's just say our game supported custom skins that players could make, yeah? And let's just say our game was a bit more high fidelity than what it is now. Let's just say that every time someone connects and they have a new skin that the server doesn't have, the server has to get that skin off them, and maybe it's like, I don't know, a couple megabytes or something. So you could compress that data client side so that you essentially end up sending less data, and then you could decompress it on the server, for example. So that's a good kind of trade situation where you're just like, I want to trade network bandwidth for CPU time. So less network bandwidth, so I'm trading like size essentially. I'm sending less over the network. What I mean when I say that is that I'm spending less time on the network and more time on the CPU rather than the other way around, which is what compression can do for you, essentially. So you spend more time on the CPU and less time actually sending packets. So less network usage, more CPU usage is kind of the idea. Series is something that I haven't actually used yet. I'm not sure if I will. So this is what this originally was going to be, whether or not this is part of a series, and potentially which packet in the series it will be in. Again, this is kind of right now taking into account both files and network packets, which is a bit all over the place, but I might just focus on files first. Name size is the amount of bytes that name takes up. Name is the name of the database. Object count is the number of objects that the database contains. RC object is the actual object, and this is the array of objects. So let's dive into that. So an object has a type. The object has an object type. So an object type is different from a type because type is the data type that is in the object, whereas object type is the. By the way, if you guys are wanting C++ streams, I would probably encourage watching this because this is very low level kind of stuff that will benefit you greatly, because I'm going to be doing probably 80% of a similar thing in C++ for Sparky eventually, okay? Because this is Sparky's serialization, basically ported to Java, but I haven't actually implemented it into Sparky properly. It's kind of just standalone still. But anyway, so I would encourage you watching this because the, what would I call it? The techniques and whatever, the concept remains the same, is what I'm trying to say. Okay, so yeah, so what do we have? We've got object type. That is actually, if you look at object type, so serializer right now, there's a class called serializer, which is a bunch of static things right here. So we've got static functions, we've got static, we've just got constants here as well. So you can see there's type unknown, which actually isn't used and probably won't be. There's type array and type object. So type object, type array is basically the object type that an object has. So basically an object is either an object or an array. Now type is, so this is like the type of the enclosing kind of data structure, whereas this is the type of the data that's inside it, okay? So that's why it's a short as well, because there are many more data types than like 15, or what there will potentially be. So we have type string, int 32, int 16, so we've basically got an int and a short, byte, float, bool. This one might be cut out, might just go as 32-bit integers, because I'm just thinking about the game programming series, and I don't think that has any shorts anywhere in the code, to be honest. We can probably have doubles as well, and longs, so like int64 or something. But this is right now all we have. That covers the majority of things. These are primitive data types. So obviously something like a vec2, for example, vec2i or something would be two of these. Whoops, would be two of these, okay? So we have the name, okay? And the name, this kind of structure here doesn't actually represent the layout in memory either, because obviously we will have something like the name length first, and then the name, and then the data length, and then the data. So anyway, Um, so, uh, that's the idea. And then you can see that this object type is set to type object. And then we have this data, essentially. So a serializable is just an interface which has two things. It's got a get type, which is a short, and will return one of these types. And then we also have this get bytes, which is actually what will get the raw data that you have to serialize. So this, yeah, so that's an interface that will kind of enforce all that stuff. Now, speaking of which, there's two kind of types of things that you can shove into a database right now. There's an object and an array. So just to cover those two real quick, and I know that this might not be making sense. The chat seems to have gone silent, so I don't know if they're all listening keenly and maybe trying to work out what on earth I'm saying, but bear with me and I'll hopefully explain most of this. So, count on it. So, there's two things that belong in a database. So a database is essentially, again, a collection of arrays. A database is a collection of objects, right? And objects, and then the database is something that you kind of finally write out. So a database is a database would be something that you write out into like savegame.dat or something, or .bin or whatever, right? That's what you write out. And then that contains a list of objects, right? And objects contain, essentially an object is just an identifier, like a key and a value, okay? So we have a key, which is like the name of an object, because we need a way to retrieve a particular object, right? Unless it's something like an unstructured object or something like that, which we won't talk about right now. We have that, and then we also have yeah, so that's an object, right? So if you wanted to store an integer or something, you would add it into an object and then add it into a database. And then we also have an array. An array is kind of like an object. An array is not an array of objects. An array is an array of primitive data types. So for example, let's just say that rather than let's just say you have an array, like for some reason you wanted to serialize all the pixels, like you're saving like a screenshot, or I don't even know why you would do this, but for example, you wanted to serialize every pixel on the screen. Maybe you want to broadcast it on Twitch or something, and you wanted to just save it and send it over a network. So ignoring compression and stuff that you would do to it, you want to save out like 480, for example, 1,000 or 1,000,000 pixels, right? 1,000,000 integers. Instead of encasing every single integer inside instead of encasing every single integer inside an object, inside an RC object, which is a rain cloud object, which would be crazy because it means that it has all the overhead of having to have a name, having to have a type, having to have an object type, and then having to have that data as well as obviously the lengths of these things. That's so much overhead that it will basically probably, like the actual integer here, honestly, would take less space than the actual overhead that it would have, right? Because the overhead has way more. So instead of doing that, if you had 1,000,000 integers that you knew were in a specific order that you didn't care about and you just wanted to shove them in, you would use an array instead, okay? And all this does is it kind of just stores everything in a row here, and everything kind of works out well. So that's what the array is for. An array is a type of object as well. So it's fine, and of course you can set that to any type you want. An RC object should probably be a template kind of thing, or rather a generic thing. Okay, so questions from Nicholas the Greek. Would it be possible to use an ID number instead of a string just to minimize the overhead? An ID number instead of a string. Where? Oh, I see what you mean. You mean for the name? Yeah, you could. The thing is, this is a byte, so you could put anything in there. This isn't necessarily a string, it's just a byte. I think something else like database might have had that name. You can theoretically put 1 byte of data in there. It just says like 1. So you could do something like that. 1, that's just 1 byte, right? And then of course you would need another descriptor for the size of that, which would be 1 as well. So you could theoretically do this in 2 bytes. So that's not really too much overhead. But yeah, you could do something like that, obviously. This can contain any kind of, this is just a key that is basically a bunch of bytes, okay? So it could be anything. It's actually not a string. You might choose to interpret it as a string, which is, for example, like if you do this. So I've like written an object which has the key, this is an int, and then I'm trying to read it now back as an integer. So this would be something like int value equals, right? And you could do something like that, and of course you could maybe slap in an identifier in there if you really wanted to, and then that would just look for a key that is that. And that, I guess, would minimize some overhead, but it's not really something that... This stuff is kind of client-side anyway. This isn't... when you send the data, it's just... Obviously, you wouldn't send probably strings this long if you could avoid it, but... Yeah. Okay, so... yeah, so I feel that's probably pretty much it. Like, there's not much... It's pretty simple. There's really not too much... serialization isn't this massive kind of problem. Serialization becomes an issue when you start to... serialization becomes an issue when you start to complicate things by trying to automate it. So when you're like, oh, I want to just be able to send you an entity, and you should be able to serialize that magically, without actually having to implement a serialization method or something like that in it. That's when it becomes an issue. When people try to automate it. So pro strategy, just don't automate it. This footer, by the way, here that I just noticed, that's just like a confirmation kind of, you have reached the end of the packet. So if there's no 1, 2, 3, 4 at the end of the file, it's like, well, this is invalid, or this isn't the end. Expect more. Anyway. Okay, so questions. So if the RC object takes in an RC serializable, how do you give it a primitive? Yes, good, beautiful. I haven't gotten to the primitive data thing yet. I'm still not sure if I want to keep this around, by the way. As I said, this is early in development. So maybe object will just take in a primitive type, because it looks like all they can take in right now is a primitive. No, actually no. Yeah. You can give it, since you're giving it a raw piece of data, you could technically implement RC serializable in, say, entity. We'll do some experiments here because I'm not 100% sure how this is going to work yet. And I'll get to all your questions in a minute, don't worry. So, yes. So right now, in order to actually take in a serializable, you have to wrap it in a primitive. Just how you do it. That's how you do things. So if you want a primitive, yeah, you wrap it in primitive data, which just has the type and the piece of data, which it will resolve automatically as well. And you can see it will basically, okay, so these have been written out. I need to optimize some of this stuff. But yes, so you can just wrap it in primitive data by being like, I want to send a float 5.5f, then I shove it into new primitive data, and I do something like that, okay? So that's how it works. Again, I could have done something like add RC object, that, but then the problem is, and we might make things for that, but right now wrapping in primitive data is how it works. Again, subject to change might make it a bit more simple. So yes, so you could technically make a private class entity implements RC raincloud serializable. Again, the reason I haven't just called them serializable is because that's actually a thing in Java, as you can see, and I don't want to really conflict with that. Anyway, so if you have something like this, you'll notice that it has to have a get type and get bytes. So get type is actually something that I should change. Oh, actually, you could do something custom here, couldn't you? This is where it becomes a problem, because I'm not sure how this will work. Basically, get type is needed because that's how it figures out the size, but it honestly could figure that out from this byte array, since obviously the length of that will be the size. But basically, if you had something like, this will be changed, by the way. There's no way that I'm going to expect people to convert something into an array of bytes first. It'll probably be more or less something like object, RC object get, or RC object serialize. It'll probably be something like this, and then basically you'll just, or even void serialize RC object, and then you can do something like object.add, or rather, oh yeah, maybe you would have to wrap it. In this case, maybe objects would have multiple primitives or something like that, but you could do something like object add, integer 5, or sorry, X, for example. So here we go. Here's another kind of use case. This would almost be a database. Objects within objects is going to be a thing, by the way. That's why I'm kind of showing you guys this. So private int x, y, for example. Let's just say you had this. So this is good. I'm writing like a kind of test case, which is important. So we have an entity has a name and an x and a y, for example. So the way you do that is you add, you create a new object. So RC object. You could even, you know what? You could even just take in a database and then do something like db.add object. So many different ways you can do this, really. RC object equals new RC object. We'll call this something like entity. Again, this does become a problem because every entity is going to need a unique name. We'll deal with that later. So we add the x and y, and we add the name. Okay, and then we add it to the database, and then that's it. That's the idea. So we could implement something like that. It's just that you wouldn't typically have this here, or at all really. Like this situation you wouldn't really have here because there's no way to deserialize that at all. Because when you think about it, you're like, well, if I'm just adding a bunch of objects, like obviously in a level, for example, you would have so many objects. You might have so many entities, rather. You might have like 50 entities. So at the moment, every instance of entity is going to have the name entity. Of course, you could do something ridiculous like add the hash code or something to the name so that it would be unique based on the instance, but you're never going to be able to retrieve something like that. It's just very, very weird. So you wouldn't do anything like that. Rather, you would just need this data, right? Where you just add this stuff to it and it takes care of it. In fact, it would probably be smart to just provide an RC object which just takes everything in, because that way it doesn't matter. That means every entity gets provided with an object of serialization and everything gets pushed into it, and that's it. And then that is actually all you need in serialize. You just serialize the data you want and that's it. And deserialize would kind of, you could have a deserialize as well, which kind of does the it the other way around. And you don't need to do it this way. This is just an example. And then the reverse of that obviously would be as simple as name equals obj dot get string name. And then you would have name here. So we might make this work. Right? There you go, done. So that's your serialization and deserialization. So you could do something like that. I think we will implement something like that because I quite like it. It's quite clean. Again, this is somewhat of an automation layer, which is going to complicate things, unfortunately, but it's nice. Okay, so Slow Turtle had a question. Why are you writing your own serialization if you have a Java serialization and you could do observer and visitor pattern for packet casting using? That sounds horrific. So first of all, I'm just not a fan of Java serialization. I used it 2 years ago, so it hasn't been 2 years since I've used it. I might not have used it properly, but I absolutely hated it. Because the whole idea of, first of all, stuff like object input and output streams is just awful. And then they've got this whole serialization interface, which really doesn't do anything, and then you have to implement. I've used quite a bit of it, and I absolutely dislike it. That's reason A. Reason B is it's actually rather slow. It might be faster now in Java 8. I think Java 7 or 6 was the last time I used it, but it was kind of appallingly inefficient, as most Java things are, compared to something like this. And the third reason is that this is kind of a game programming let's make things from scratch without using libraries thing, right? So we try and do as much as we can because this is all about learning. And being able to use Java serialization is something you can probably look up and use very quickly, very easily. And I could do that in one episode, but rather than doing that, which is kind of weird and slow, I would rather do something like this and implement it myself, which is what I'm doing. Okay, cool. Anyway, that's the idea. And also, obviously, it's going to benefit you guys. But that's the idea. So, now that we've got a kind of an API situation going on here, So objects can contain primitives just like this. This might automatically wrap it in some kind of thing. I don't know how this is going to work exactly in Java, because in NDNS is actually another good question. We're going with little endian because that's just how things work. But which means that the most significant bytes are going to be on the left. So the most significant bytes are going to be kind of the first bytes you read. But we're going like that because I like that. But yeah, endianness always kind of confuses me, and I sometimes get it wrong, but just rolling with it the way that it is right now. And we'll open this file and I'll show you guys what I mean actually. So let me just get that file out. So that file, whoops. That file is right over here. So this is the kind of format right now. So you can see that we've got the header, then we've got the whether or not it's compressed or something like that. What's the format? Yep, compression. We've got series, which apparently, oh no, sorry, that's the version. So this is version 1, right? That's compression, so 0. That's series, which is 0. That's the size of name, so it's a short, so it takes up 2 bytes. So it's 6 characters, yeah. 1, and then the name of this database is Cherno, so 1, 2, 3, 4, 5, 6, yeah, Cherno. Then we have a 0, which is that's either the object count or it's actually the null termination character. I think it's just the object count though, right? Yeah, it has to be. It's part of the object count. So the object count is 2, yeah. And that's our first 16 kind of byte block. Then we've got the... Oh, sorry, that was... Yeah, that's right. That was object count. Then come the objects, right? Object count 2. And then we have... What is next? Oh, that's right. So now we're an object. So we have object type. So object type is 20, which means that it's an object. Or no, that means it's an array, right? Yeah, so 20 means it's an array. So there's that 20. Then we have type, another short, which is right, this one right here, which means it's an integer. Because if you look over here, again, this stuff is subject to change, but there it is, int 32. Next short is the name length. So the name is 5 characters. That's actually wrong. Is it the name length? Let's see, what do we set? It is, wait, what? Type is a short, that's 5. How's that 5? That's so very wrong. Name length. Oh wait, hang on. No, that's the count. Because we're not in an RC object, we're in an RC array. That would be the count. So there's 5 elements in the array. So 2 identifies it as an array, which means that the next byte has how many elements are in the array, the size of the array, and then we just have the name. So how do we don't store the size of the name, do we? Type count name, no we don't. So that's something, that's a to-do. Otherwise we have no idea when the name stops. So there's the name, test int array. Then we have the integers. So that's integer number 1, which is value 1. So this stuff, by the way, is coming from here. There it is, 1, 2, 3, 4, 5. Yeah. We've got 1, we've got 2, we've got 3. They're 4 bytes because they're integers. We've got 4, we've got 5, and then that's it. So this stuff after that is going to be the next object, I believe, because the array doesn't really have a closing footer, does it? No, that's actually it. So the next thing would be another object. So we've got a bunch of zeros here, which I'm actually curious about what they are. I mean, I'm assuming that it's straight into the next object, but that is a bit... Wouldn't it be? That's the last element in the array. And then we've got a lot of zeros, which is a bit weird. I think we're not serializing object type. We're not. That would be why. We need to fix this up. That's why I'm streaming this stuff though. Because this stuff needs fixing. All right. So, show. Quick question here. Am I better off learning Java or C++ or something else first? I would go with Java first because it's a lot easier than C++ and it won't bore you with the details of computers too much. And you won't need to worry too much really about how everything works, and it's just, yeah, it's going to be easier is what I'm trying to say. Yes, I would. Yeah, I definitely do Java first. Another quick question, Cherno, are you still working at the company you used to? If you mean EA, yes, I'm still working at EA. Things are going very good. It's nice. I enjoy working there a lot. And hopefully I'll be working there for the foreseeable future. The unforeseeable future, I should say. Yes, this cloud stuff is for, it's kind of all the server networking code for Rain, the game programming game. But right now we're focusing on serialization, which is both going to be used for networking, so for sending packets, for packing data into network packets we can send, but also for files. So when you want to save game data as a file and read it. Okay. Yes, and this is a pain to implement in Java. I'm not gonna lie, it's not very fun. Like, as well, this stuff, I don't even know if this stuff is going to be possible. I assume it is, it's just that it's going to be a bit more slow because generics work a bit differently than templates in C++, and this would be a lot easier with templates, to be honest, because we could implement functions that basically already exist for each of these primitive types, whereas in Java, it's like, we'll probably have to check them at runtime or something ridiculous. So it's going to be even slower. I don't know. I probably shouldn't be doing it this way. The way I should be doing this stuff, by the way, just so you guys know, probably, is something like this. Except I hate that. It looks horrendous. I don't like doing anything like this. But that is probably the way I should be doing this stuff. I'm doing it so that it looks good syntactically, and I'm also doing it the way that I would do it in C++. Which is, again, not good advice, and I probably wouldn't take it. If you're writing a commercial game in Java, which first of all is your first mistake, but anyway, that aside, if you're doing something like that, then I probably would not, I would probably vary this a little bit, not too much. I'll be really interested to do some benchmarks on this when this is done though, and compare it to something like the C++ version of this code and see how much faster that will be, because the answer is a lot. All right. Anyway. Yeah, you could make getInt, actually. You could do something like that. So, I might, yeah, that's actually, yeah. So you could do something like getInt, which would look for an integer. That's probably a better way of doing it. The reason I like doing something like that is because in C++ it would make more sense because you can do stuff like that, for example, and that stuff can be kind of calculated at compile time rather than runtime. And that would be nice, obviously, and it looks good. But something like that wouldn't be, because it would have to be a concrete function that you actually write, which obviously you can't do because that would make it very game specific. So yeah, you wouldn't necessarily need to do it this way. This is just kind of a way to do it. But yes, actually getInt, getFloat, getByte is probably what we'll have to do. Otherwise, this is just going to get out of hand, and it'll be way too slow. So the same with add, really. We will probably have to do something like add string, add integer. It's not going to be fun. Java. Okay, so and I had read before in caps apparently. All right. So for this to work, we need objects to be able to contain multiple primitives, and I'm thinking of ditching this entire primitive data situation as well because it's not that great. Also, it's incredibly hot in here. I need like a little fan or something. If only you guys were actually real fans, like ones that blow air. That would be so much more useful. Quote Cherno. Alright, so I've said a lot of stuff today and I've done nothing, which is not good. If I did not stream this, I would have done a lot of things and said nothing, which is probably the preferable option, really. So we're going to pretend that didn't happen. The other thing I'm going to have to do is write the reverse of this. So I've focused on serialization, but not deserialization yet, which is also not great. Anyway. Yeah, something like object count could be calculated from this as well. A lot of this stuff could, name size from name, but it's better to keep it like this because that's actually the structure of it. Not that that matters. See, the cool thing about C++ is that if you wanted to, you could make if this was like a struct or a class, doesn't matter if it's a class or a struct, but if you had a class called format, for example, and you wanted to deserialize this stuff, you just basically point it to the beginning. You make a new format thing in memory, and you point it to the beginning of your data, in your serialization data. And because this stuff is all in a row in memory, it will just magically line up. And you do that all in one line. Suddenly this entire object gets set, and you're done. And you don't need to even allocate memory for that if you've already loaded the format into memory. It's amazing. It's just so fast, and it's instant. It's not actually an operation. So unfortunately that's something that you can't do in Java. Okay, anyway, all that stuff aside, let's get down to some business. Because it's been like an hour. Wow, I need to reassess my priorities here real quick. Okay, so what do we got here? I began doing stuff like this. Okay, so the other thing that's important is potentially having an object definition and a field definition. So fields are something that I haven't implemented yet. Fields are essentially kind of what I did here. So this would be a field. So name would be a field, yeah? X would be a field, Y would be a field. And fields are basically kind of objects inside objects in a way. So the way this works hierarchically right now is that you have a database which contains a bunch of objects, and you have an object which contains a bunch of fields, and then you have fields which contain a single piece of data, okay, like a primitive data essentially. Arrays in this case could either be implemented as fields or not. It's really up to you. But in order for you to be able to do something like this, you need to have an actual object. So when you deserialize it, this stuff is going to be a bit difficult to do at runtime, to be honest. Because, like, you know, what you create a new entity and then you run deserialize with an object. You could do something like that. You could also create an object based off of that. Okay, let's do this. So field and field definition. We'll do it this way. So field, a field will have a field definition, which I'm actually just going to leave public. A field definition will have stuff like, this stuff is probably just going to be public really. A field definition is going to have a type, a size, and a type and a size, and an offset. This is actually probably going to be a long. So basically I might start documenting this a little bit. type of data in field, size of data in field, offset of field in database. So this is just like a byte offset. And then obviously you have a field containing a bunch of data. So that's what a field has, a definition and data. Okay, it's definitely got a name as well. It's something that I forgot to put here. We have offset, and then I guess we'll have name. So we'll have name length, and we'll have name. Okay. Oh, the face cam's covering the comments. Yeah, sorry. I keep forgetting that I shouldn't make columns in Eclipse. There we go. Okay, so that's what we got going on here. That's basically what's in the field definition. Now, field just has that definition and the associated data to it. So when you read a field, in fact, you probably wouldn't even have a field object. I'm not even sure if this class needs to exist. Because when you have an object, let's just say we have this public void add, and let's just say we have like an int version of it, int value, string name. We could store this as like a map potentially here. We would need to actually. I wouldn't really store it as a map. Yeah, so in this case we could, okay, so you could do two things. You could store it as a map and then iterate through the map when you write it out, or you could store it as an object, as a list of objects, which is really the same thing. Yes, this is going to be used to save data to a file. Okay, so this is going to be used for both. So serialization, this serialization will be usable for both files and network streams. Any stream really. Serialization usually applies to everything. And we will be using this in game programming to write data to a file. Okay, so in this case, we'll have a bunch of fields. And then we'll just basically do something like fields.add new RC field. Name the value integer. I mean, the other problem with this is that what do you put here? Question mark. Which is why that's not a good idea. So what we do instead is we have RC field with name and a value, and we resolve that obviously based on the type. So when we do something like this, oh man. So let's implement this for integers. This is not very nice. Int value. So definition equals new definition. What do we have in definition? So type. So in this case, this is going to be int 32. What's next? So size. So size is obviously, okay. Well, in this case, size is really just going to be, we could implement something like this. I might actually do that, to be honest. That doesn't exist yet, but it will. Because I did have something like this, maybe. But basically, we will we'll kind of just go through this as it comes. Because Java doesn't have that. Variables are not private because I want to access them like this and write to them like this. There's no reason for them to be private whatsoever. Since this is a pod, plain old data. So offset, we actually have no idea what this is. We don't really care, quite frankly. Name length and name. So name length is going to be name.length, and name is going to be name.getBytes. All right, there we go. So we've filled out the definition, and then the data, of course, will be sent by just doing data equals serializer dot get set bytes. Oh, I see. Oh, I see. This was actually quite nice. Yeah, we could do that actually. Yeah, we could do that. So data is going to be equal to, this is much worse than what I had before, to be honest. Than what I had before I started this live stream. We could do something like definition.size, and then we could just do something like serializer set bytes data 0 and source is value. Technically that would work, and that would give us a field, and then obviously at the end when it comes to serializing this, so public byte get bytes, that would be pretty basic as well. We have a result, which is get packed size, which would just be the size of the definition. So equals definition dot get packed size. So the size of this is going to be 2 plus 2 plus long, so 8 plus 2 plus name length. Okay? And it's unfortunate we have to do this instead of just being, again, in C++, you could actually do something like size of, like this, essentially. But can't do anything like that here. Okay, another question from Next, or however you pronounce that. Wouldn't it be easier to use byte buffer? It would be way easier to use byte buffer, but byte buffer is incredibly slow, so we don't want to use byte buffer. But yes, byte buffer would be easier to write, obviously. You just have to make a byte buffer and then push whatever you want into it. But doing it this way is much faster. Okay, that's why we're doing it. Okay, so yeah, so we've got this. Result is definition. Why is that? Oh yeah, whoops. That's what I meant to write. So this returns an int. So it's definition.get packed size. So this is actually pretty simple. It's just going to be that plus definition dot size. That's it. So it's the header of the definition and the actual thing. That's it. It's pretty easy. So now that we've got the size of the entire thing, it's time to serialize it. So we just have to do something like int pointer equals let's quickly import that as static, to be honest. Get rid of all these. Okay, cool. So pointer is going to be set bytes, destination being result, pointer just being 0, because it's start. Another way to do this would be to actually pass in an existing array and just do that, obviously with a pointer. And you could do something like that instead, and that would be way faster than allocating all over again. But we'll implement it like this for now. We'll get it to work first, and then we'll optimize it like crazy. And that would also make for some interesting videos, I think. Anyway, source of data will be definition dot get bytes, which is about to happen as well. So get bytes is going to make a new byte array, get packed size, and then it's just going to be int pointer equals, and then we'll just do stuff like exactly the same thing we had going on here. So something like set bytes result 0 type size we don't have one for longs yet, which means it's probably getting cast. Let's make one for longs. So long value. Oh man, this is gonna be huge. Oh man. Alright. Here's what I should have done. Whoa. Alright. So 32, 48. I just went up too much. I missed 40. That's also way too much. What am I doing? 56. Alright. So there's your long. It's a long value. We probably don't need this to be a long. Oh, this doesn't get serialized also. What am I doing? We don't need to serialize that. Think cherno. Offset is purely for, that's not for, I mean, technically we could serialize that. No, we don't need to. We don't need to. This is to do work this out. Definitely not something we serialize. Name length. So that's easy. And then finally name, which is just name. Okay. So pretty simple, and then we've got the result. Cool. So now that we've done that, we just need to do set bytes, and then also set bytes for the data. All right, cool. That's it. That should be fields done. Deserializing them again is going to be problematic probably, but we've got fields now. Good. So when we do that and we get the back data for the object now, it's going to change a little bit because it's going to have a list of fields. So the way this is going to work is we have an object type. That's still something that I potentially want to have, maybe even not. So this is like, consider removing. We definitely need a type. Oh, no, we don't actually, because it's just a bunch of fields now. So type is actually gone. We still need the name, and we actually do need the name length and the name. And then we need to have the data, which is now just the fields. Okay. And then obviously we need to have the field length. That's just how many fields there are. Okay, cool. So name length is just going to be name dot length. Class into a short, so we can't have names longer than 32,000 or whatever, 32,500 characters. Something to keep in mind. And then and then, what's it doing? Yeah. All right. So we have. Oh wait, what's it doing? We've got the name length. We've got the name of the field length now, which we don't know yet. And then that's it. And then the fields. Cool. We'll keep that separate for now. So pack data. So what do we need to pack? We need the object type, name length, data length. We no longer work out. Pointer equals 0, size equals get size. So this needs to be get packed size now. So the size is going to be this. It's going to be, we need to know the size, which is a bit of a problem. How do we find out the size? We can find out the size from every field, right? Get back size. Find out the size of the entire object. Yeah, we could do that. So 1 plus 2 plus whatever that is. 1 plus 2 plus, so we've gotten rid of that, which is good. 1 plus 2 plus, oh no, this, oh, that's object type. Oh yeah, we don't need type anymore, that's fine. Plus the length of the name, plus field length, so that's 2, plus data length. So plus data length is now going to be plus, okay, that's a problem. Public int get field size. So for field f in fields result plus equals f dot get packed size RC field. What? Okay. Done. Plus, that's it, I think. Get field size, because that contains everything. I think that's it. So get packed size is now something we can shove. That's not used anywhere else. Something we can shove into here. Pointer is something we can kind of just hacksaw here. So set bytes. So first thing we set is the object type, of course. Then we set the name length. Then we set the name. So we can just do that normally. No need to go crazy about that. Done. Next we can set the field length. Field length, done. And then after that we can set up the actual fields, which I believe, so that's count, yeah, that's field length. So whenever length is written, it's usually the size of something in elements. So in this case, it's the size of, it's how many characters there are. In this case, it's how many fields there are. It's not like a size. If it was size in bytes, which it coincidentally is for name but not for field, it would be size instead of length. That's a little naming convention I'm rolling with. Okay, cool. So yeah, so the final thing we need to do is just get rid of all this and just chuck in something like set bytes. Now we have to do the four things. So for field, for RC field, I'm just going to call this field. Fields pointer equals set bytes. Field dot get packed size. Sorry, what? Get bytes is what I meant. That's it. Yay. Cool. Pretty awesome. So now we're good, I think. So objects have let's just go through this quickly. Get packed data, which is this. So we had get packed size. Why do we need that? We don't need that anymore. Oh yeah, how do we know we've finished the object? Oh, we know by the object count. Yeah, I'm gonna say we probably don't need this. So like, what is object size? Where is that actually used? Oh, we do need that because we need to know what the size of the object is. But we know that anyway because we have multiple objects. Yeah, we definitely need this. So this will just be get packed size. Because we need to know how big this is going to be. So let's just verify this. 2 bytes for the header, 2 bytes for the version, 1 byte for compression. That's already wrong. Did I get rid of something? Why is that 2 plus 2 plus 2, right? Plus 2 plus 1. That's weird. Okay. Plus 1 plus 2 plus the actual size, which is this. Plus 2, so count, plus object size, whatever that is, and plus the footer. I don't know why I had an extra 2 bytes in there, that's weird. Okay, that looks reasonable to me. So let's run it and see what happens. What errors do we have? Read stuff, we'll comment that out for now. And this is just a test case. And that's not done yet. So array test, let's not do that. Let's, you know what, we could do something like this actually. Let's uncomment this. So right now what we can only add integers, I believe. So let's just do x and y. Deserialize can just go away because I'm not ready with you yet. And then this can also go away. Okay, so object dot add. So what did we actually call it? Let's just add. Okay, there we go. That seems to not error me. So let's see what happens when we static void obj test. So we make a new database. It doesn't actually matter what it's called right now because we write it to stream.bin anyway, which will change later. I've kind of made the whole get byte system because why not? But db.add new. Okay. Okay. So here's what happens. Object RC object entity equals new RC object entity. Okay. So this is where the data comes in because that's not a thing anymore, and I don't think it's used anywhere. Is it? It's not. Beautiful. So there we go, and then we can just do something like entity e equals new entity. Why is that an error? Oh, it's not even static. Okay, let's do that. This is going to error me. I've actually just destroyed everything, by the way. Everything I worked for. It's okay, this is much better in the long run. Probably. It's gonna need a lot of optimizing though. So let's make an entity 5, 8. Those seem to be my two favorite numbers. Done way too much programming today. All day at work and now here. Lols. It's already 10:30 as well. Wow. Gotta go soon. Gotta go to bed soon. Big day tomorrow. Okay, so, and then we'll just do entity serialize entity. This should be object, really. This should be called entity. And that should be the best. Oh, and of course we need to not forget to add object into this thing later. Okay, so that's kind of the deal. We make an entity. The entity does stuff. Then we decide to serialize it, so we make an object. And then we add that object into the database later. Pretty standard stuff. So let's see if this doesn't crash. It crashed. Not a good start. What's up? Array index out of bounds. In set bytes. Okay, so clearly we did not make the array big enough. 50, wow, okay. 50. Okay, that's reasonable. Where is this coming from? Ask the object get packed data. So fields, how many fields do we have? 2 fields, correct? Field number 2, I presume. I don't know, because I made a for each loop instead of for loop. Silly. Get packed size just had to have been wrong. Field.getBytes. So what is out of bounds, actually? That would be a better question. How big is dest? Why are there 2? No, they're not. So dest is 49 elements large, and we're trying to access some of 50. So that's too big. All right. So what happened? Why did that not give me the right size then? So what is get field size, first of all? Fields like get packed size. Definition plus definition of size. And definition size. I'm not seeing where that gets set up. That's because it gets set up here. Size of that, which is going to be 4. Huh. That looks kind of correct to me. I'm not sure why that's lolling me. Field.getPacked size. What did get field size return? I need answers. How big was this? Well, we know actually. We know it's 49 elements. So 49 elements. Do we want to manually count this? I really can't be bothered. Point is only 31 until we start writing. Those fields seem big. So, oh, this is annoying. This is very annoying because that should not be wrong. Size, definition. Is that all we have? Really? 2 plus 2 plus 8. Oh, 8 is wrong, first of all. We don't serialize that. Why is it there, though? That would even with that, it was out of bounds. What? So, 2 plus 2 plus 2 plus name length. Did that get set properly? I don't know if that gets set at all, really. Did we set that? Where are we? Yeah, we did. It's name.length. Yeah, that gets set. What is it set to, though? Let me look at it, Java. Hang on. Where am I? In RC object. Okay, so... Oh, that's going to help me. So for this field, definition for size 4, name length 1, that's correct. Name is bytes. That's an X, I presume, or a Y. Type 2, size 4, that's correct. Everything seems correct. I think I was onto something though. Where was my field definition? Because that was wrong. Name length, length of name. So this doesn't. Yeah, this is just a header essentially, because the field definition is a header. Weird source. Weird source. Don't know, man. Let's launch that again, because we did fix that bug. I mean, I'm presuming it will still crash, yeah. Oh, this is in a different place. That is in a different place. Wait. No, it's not. So now this should be even smaller. It's 32 now. Is that large enough? What's that for, first of all? That's an RC object, get back data, so that's in here. So it decided to make one that was 33 elements. So 33 elements, large, to contain this object. Was that enough? Let's count. 33 elements, right? Sorry, 33 bytes to contain this one object. So we have, that's a lot, first of all. Oh, it's got 2 fields. Yeah, I can believe that. There is a lot of overhead in this, though. You'd probably be better off throwing this as an array, but anyway. So we have 1. So 33 is the thing we're calculating here. So 1 plus 2, so 3, plus whatever name length is, which is 6. That is wrong. That can't be right. Oh no, that's the name of the object. So the object is called Cherno, which is 6. So 9, we're at 9. Field length should be 2. What? Oh. Lols, I forgot to set that. That would be why. Good one, Cherno. Not that it was like used anywhere. Oh no, it was too. Field length. Still, that shouldn't have affected anything. So that just gets set to fields.size. I don't know if that'll fix the problem, to be honest. Yeah, that wouldn't have done anything. Alright, so back to the drawing board. So 33 is our size, let's verify. Yep. So, 16. Oh yeah, it's in decimal. So 20. Whoa, hang on. 20. That's 10. Yeah, my bad. I meant 10. Okay, so 3, 9, right? Yep, that's yep. We're at 9, 11. Okay, so 11 is the base object. That's the object header, 11 bytes. Fields. So there are 2 fields now. Let's look at them. So field 1. Yeah, that's fine. So we're at 11 bytes. Field 1. RC, so field 1. So I wish this was in order. I guess it doesn't really matter. So field 1. So we were at 11. So 13, 15, not in there. 17, and that should be 1. so 18. Second object. So we're at 18. This doesn't make any sense. And obviously the bytes. So 18, so 4 bytes. So we're at 22. 22. So 24, 26, 28, 29 plus 4, 33. That's perfect. 33. That's it. 33 bytes. What's the problem? Why are you lolling me? How am I setting this? Definition and the data, which should be 4 bytes large. But it's not. That is the definition. Oh, no, definition of size, which is 4. And you're setting the bytes. Hold on a minute. Let's look at this. Yeah, I can believe that. So, data, 4 bytes. Yeah, it's 5. 5 and 8. That's what we agreed on. This is so confusing. Why is it not working? How is it? Why? Okay, we're gonna have to step through this, obviously. So, result. Nicely allocated 33 byte array. We write the object type to it. So we're 2 bytes in. We write the name length to it. We should be 4 bytes in. We write the name to it. We should be like 10 bytes in. 10 bytes in, good. Field length to it, we should be another 2 bytes, so 12. And then we start writing the field. So this is where things get messy for some reason. I don't quite know why. So pointer is 12, so we start writing address 12, or byte 12. So we make a new byte array, and this is going to get bytes. So we expect this to be like, this is the field. So we have a new byte array, which is the get packed size, which is 11 large, as I said. So we're 12, 11. Checks out, I think. The next one, wait, this one's 11 and the other one's 11, then we do have a problem. But that took that into account, didn't it? 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, okay. Still should be good though. 7. So the header was 7 bytes. And then this takes us up to, well, we don't know because I didn't return it. Alright, that's the first one done. So now what are we at? 23. So we've got room for 10 more bytes of data. Whereas I think we should need 11, shouldn't we? What am I doing then? Raresica, or Resica. 1, 2, 3, 4. There's your hello. I don't know how to pronounce your name, but there you go. Sorry, just interacting with the stream. People watching this on YouTube. Why are these red, first of all? That's a bit weird. Oh, it looks like those are the ones that have changed since like last time I looked at it, I guess. But they're all the ones that aren't 0. Yeah, okay, whatever. Anyway, pointer is 23. So this is probably going to be too big. It's 11. So it's 1 byte too big. But it's get packed size. So field size should return 22. That should return 22 then, in that case. 22 bytes plus 2, which is 24 bytes, plus 3, which is 27 bytes, plus name length, which is 6, which is 33 bytes. What's wrong? What is up? Wait, what? Hang on. So, pointer right now is it's, yeah, sure, whatever, this gets its own bytes anyway. And then it crashes because pointer was 34. Source length. What was I? 10. So it was on the last element. It was going to write the last element. This stream will be uploaded to YouTube. It'll be on the Cherno archive channel. If you're not subscribed to that, it's youtube.com/c/Cherno archive. Go to that and subscribe, and it will be posted there. Probably tomorrow. Alright guys, I do not understand why I'm miscalculating by 1. I mean, it's weird. It's very weird. It's probably going to be something really stupid as well. So, we've already gone through the fact that this is 22 bytes. Yeah? Has to be 22 bytes. 11 times 2 is 22. So 22 bytes plus these 5, 1, 2, 5, yeah? Is 27 bytes. And then this is... Wait, hang on a minute. It might be including the null character. I don't really know. Because this is Java. No one knows anything for sure. Because this is 6, and if this is 7, no, it's 6, so it doesn't include the character. What is wrong? Didn't we have we had like an extra 2 bytes here originally, which I thought was weird. So, object type. Wait, are we writing that properly? Oh no! I was writing it as a short. Because it was being implicitly cast. Son of a mother duck. Oh man, that is so terrible. It was being implicitly cast into a short because there was no overload for the function that takes in a byte. Holy guacamole. That's awful, man. That is dirty. Like, it would have happened in C++ as well, probably. But that is unfortunately terrible. So what I should have done, guys, is actually done something like this. And that's fixed. So this will work now. Once I get rid of these breakpoints. Done. That's about enough Java for me for today. It's not really Java's fault though, but like, yes, actually with warnings enabled, a compiler would have told you that you were using the incorrect data type and I probably would have figured it out. I never look at warnings though. Anyway, to fix this, we're going to actually make another overload that does take in a byte. And this is obviously going to be really simple, but, you know, I guess we can fix that up now and standardize it. Make it standard. Okay, there we go. Incredible though. Alright, so now we're done. If we look at this, this is what it looks like. This is what the data looks like in our serialization format. So the data is in here, stream.bin. It takes up 51 bytes of space, not much at all. So we've got the header, this stuff. The real fun starts over here. So we've got an object, or do we? Let me quickly refresh myself on this. I keep forgetting this, even though it's my own format that I created. So header, RC. Then we've got the version, which is a short. We've got compression, which is 0. We've got series, which is 0. We've got name size, which is right over here. Oh, that's the size of the name, that's right. Name size, then we've got Cherno, 1, 2, 3, 4, 5, 6. Yeah, Cherno. Then we've got object count, which is a short. So we've got one object in here. Okay, one object which has 2 fields, don't forget. One object, okay, and then we straight in get into the object. Okay, so this is the object. So the object is an object because 1, 0 means it's an object. If we go into serializer, we can look at 1, 0 here, which means the type is an object. Then we've got, well, back in database. We're inside object actually now. So we've got the type, which is an object. We've got the name length, which is a short. So it's 6. The name is 6 characters. Entity 1, 2, 3, 4, 5, 6. You can see it on the right hand side here. Entity. Then we've got the field length, which is a short. So we've got 2 fields in there. Then we've got the fields, I think, right? Yeah, the fields come next. So we've got so we jump into field definition. So we've got the type of field, which is a short, and this type is of course a int 32, yeah, which is number 2. That's why we got this here. Then we've got the size of it, which is over here, so 4 bytes. We actually don't need to keep the size in here, I just realized, because the size is going to be equal to the type. Look at that, saving memory, I guess. We don't need the size of the field because we can work out the size from type. So that's 2 bytes saved for every field, which is actually a big deal. Then we've got the name length. So we don't store the offset in the this does not get serialized. Name length, so the name is 1 byte long, and then here's the name, 78x, you can see here, x, that's our x coordinate. Then we've got, what comes next? The data, I guess, yeah. So here's the data. So we're back in RC field now, and you can see we've finished the definition, we've got the data now. So the data we know is 4 bytes because it says 4 bytes, but also we know that because it's an integer because the type says, it says right here. So these are the 4 bytes, it's 5, which of course is what we serialized if you look over here, 5. And then we've got the next object. So that's it, object's done. Sorry, the field is done. Next field is an integer, it is 4 bytes large. We don't need that, it's redundant. It is the length of the name is 1, the name is y, the data is 8, and that's the footer. 1234 means we're completed. Yay! So there we go. That is serialization in a nutshell. I mean, it's nowhere near complete, and we have no way to deserialize this data. But you can see how simple it is to shove in an integer into there, and it would be the same thing with a float, by the way. If we were to go into field, the only thing that would change is the type and the data, which just gets set by value anyway, like that. So, for example, if we wanted to float, obviously this is going to change. Need to implement this because Java doesn't have anything like that, unfortunately. Well, it's alright. That's pretty standard to have to do this stuff. And then if I went and set a float called float 5.8f, add there you go. Done. Run that. Go back in here. Read that file, and then you can see we've got the float, the name, which is just float, and then we've got the actual float data, which is 40 B9, and there's no way to prove that that's 5.8. The best way to do that is I'm actually just going to, this is probably a bit overkill, but I'm going to pop into Visual Studio and just do that really. Visual Studio. Yeah, let's pop into Sparky. Let's pop into Sparky and do this. So, sandbox. Let me just make sure this runs. Totes does. We could probably just pop into Votch and do something like float. Yeah, man. Ooh, that's wrong. That is actually wrong. Unless it's not, unless it's reversed. Because that's definitely not, it should be 5.8-ish. Uh-oh. What's wrong with that? Maybe I'm doing it in the wrong order. That could be a reason. Let's reverse this. No, that's not it. What have I done? That's weird. That should be a floaty float. Set bytes. Float it into bits. Bum 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 bum. Huh. Maybe this is weird. I don't know how that does its magic. Oh, that's annoying. I was hoping that would just work. But it didn't. Why? Wait. Was I just casting it to a... How was that? Maybe that's... Maybe I'm just wrong. Hang on. Hold on. Hold your horses. Yep, I was wrong. There we go, 5.8. So yes, as Roblon posted, it is correct for 5.8. I don't know what I was doing. I think I was, I think it was reinterpreting it as a float instead of actually casting it. But you can see that that is in fact 5.8. So. Okay, good. So everything's working. I can now go to bed. All right, anyone have any more questions as I wrap up the stream? Oh, actually, I've got a thing for you guys. If you are currently not following me, or rather, if you are currently not part of my Slack group, you should definitely join that, because we should continue the conversation there, basically. So if you guys don't know this yet, because this is a fairly new development, I've made a Slack team for the Cherno community, essentially. So you can head on over to slack.thecherno.com, enter your email address here, and you will receive... I should probably not show all my email addresses just then. That was very stupid. Please don't send me emails. Go over here, enter your email address, and you will get an email invitation to the Slack group, which looks a little something like this. Just make sure I'm not leaking anything. Which looks something like this. So this is a Slack Windows app. You can see that we've got a bunch of different channels here, like for C++ and for Java and for Random and for Sparky and stuff. This is very new. This has been out for like a few days, but there's been quite a lot of discussion here. So if you join, I'm on here constantly. You can see I'm just talking to people all the time. Like I usually have this open like while I'm working and whatnot, and I will absolutely mention things all the time. And it's just a good place for everyone to chat to each other. So anyway, that is the idea. If you enjoyed this live stream, then thank you for enjoying this live stream. I don't know where I was going with that, but yes, I think you should sign up here, and I'm going to probably promote this a bit more as well. Okay, cool. Anyone have any more questions? If not, then I'm off to bed. Other than that, yes, this stream is going to be posted. This stream, I'm going to type a message here. This stream will be available on youtube.com/channel. Okay, so you can go to the channel that I just linked. This is just a little archive channel, and I post all my streams here directly from Twitch. So, good idea to go here and catch the stream if you want to watch it again. Other than that, thank you guys for watching, and I will see you next time. So yes, this is almost done. When I get this to the point where it's done, I'm going to actually make a series on this on YouTube. So do you remember how I made like a standalone video for events? I'm going to make a standalone series for serialization, and then I'm going to basically copy and paste serialization into game programming and use it. Okay, so again, I'm doing a standalone thing because this applies to everything, not just game programming. And it would be, in my opinion, a very bad idea to make this as part of the game programming series and integrate it directly in the code base. That would be very weird. I'm probably honestly almost going to just make this as a standalone serialization library, which the game programming project will just link. That might be a good idea as well, actually. I hadn't thought of that before now. Anyway, thanks for watching, guys. Hope you enjoyed, and I'll see you next time. Goodbye.